Hey everyone. So if you've ever typed docker build dot, you've used what is maybe Docker's most fundamental command. But, underneath that simple command is this incredibly powerful engine that has totally changed how we all build software. Today we are going way beyond the basics. We're going to see how modern Docker builds have morphed from these simple to-do lists into intelligent parallel blueprints that unlock some serious speed, security, and scale. All right, let's get into it. So the best way to really wrap your head around this shift is with an analogy. The old Docker builder, it worked just like a to-do list. It would read line 1, do it. Read line 2, do that. You get the picture. It was simple, it was sequential, and frankly, it was slow. BuildKit, the modern engine, is completely different. It's more like a smart blueprint. It reads the entire Dockerfile first, understands all the dependencies, how everything connects, and then it executes everything it possibly can in parallel. This isn't just a small tweak, it's a fundamental change from a linear script to a truly optimized plan of action. So yeah, let's talk about that core engine. This is what we mean by the BuildKit revolution. Now, the magic behind all of BuildKit's intelligence is a concept called a directed acyclic graph, or a DAG. And look, don't let the name scare you off. All it really means is that instead of seeing your Dockerfile as just a single, straight line of commands, BuildKit sees it as a map of dependencies. Every instruction is a destination on that map, and the graph shows all the possible routes and, crucially, which steps must finish before others can even start. And this is exactly why that map is so powerful, because BuildKit understands the full picture, that full dependency graph. It can run independent stages at the same time. I mean, think about it. Imagine your Dockerfile builds your front-end JavaScript in one stage, and it compiles your Go backend in another. The old builder would do them one by one, but BuildKit, it sees they don't depend on each other at all, and it just runs them at the exact same time. And it gets even better. If you have stages for, say, running tests that aren't actually needed for your final production image, BuildKit just skips them. It's called stage pruning, and it saves a massive amount of time. This new architecture leads us straight into our next big topic: unlocking build performance. And we're going to do that by going way beyond simple layer caching. And here is a question that I know every single developer has felt in their soul. You change one tiny line of code, you kick off a rebuild, and suddenly you're just sitting there, watching your build system re-download gigabytes of dependencies from NPM or Maven or whatever. It's so inefficient, right? And regular layer caching doesn't help here, because once a layer is invalidated, everything that comes after it has to run completely from scratch. So BuildKit's solution to this is a total game changer called cache mounts. By adding this little flag, -mount equals type equals cache, to your run command, you're telling BuildKit, hey, for this one command, give me a special persistent cache directory. Your package manager then uses it to store all those dependencies it downloads. So the next time you build, even if your code changed and that layer was busted, the cache is still there. No more re-downloading everything all over again. It's a huge, huge win for build times. And this is where things get really powerful, because you can extend that cache to your CI/CD pipelines. Local caching is great, but in those temporary CI environments, that cache just vanishes after every run. BuildKit lets you export your cache to a remote backend. You can push it to a container registry, you can use the super fast GitHub Actions cache, or for huge enterprise scale stuff, use something like an S3 bucket. What this means is your entire team and all your CI jobs can now share the exact same powerful cache, saving time and resources for everyone. But raw speed isn't the whole story. We also need to build with confidence. And that brings us right to our next section: secure and reproducible builds. Okay, here's a really common point of confusion that has major security implications. It's the difference between arg and env. Arg is a build time variable. You use it to pass in something like a version number, and then poof, it's gone once the build is done. env, on the other hand, sticks around. It persists in the final image as a permanent environment variable. And this is exactly why it is so incredibly dangerous to use env for secrets. And just let this one sink in for a second. An env instruction is a permanent part of your image's history. That means it's accessible to anyone who can pull that image. So if you put an API key in an env variable, congratulations, you've just leaked that key to the world, permanently baked right into your image layers. The right way to do this is with another one of BuildKit's powerful mounts. Using -mount equal to type equal to secret, you can mount a secret file directly into the build container's memory, but only for the duration of a single run command. It's what we call ephemeral. It's never written to disk, it's never saved in an image layer, and it just disappears the second that command finishes. This is the secure, modern way to handle your credentials during a build. And for private repos, there's a very similar solution. The SSH mount lets you securely forward your local SSH agent connection right into the build container. So what does that mean? It means the build can clone your private Git repositories using your credentials, but your actual private key never, ever leaves your machine. It's just security by design. Okay, let's switch gears a bit and talk about reproducibility. The goal here is pretty simple. Building the exact same source code should produce a bit-for-bit identical image every single time. But there's this subtle enemy working against you, and that enemy is time. You see, every file has a modification timestamp, and if that timestamp changes even by a second, the layer hash changes even if the file's content is exactly the same. While the solution is surprisingly elegant. First, you just grab a stable timestamp, something like the one from your Git commit. Then, you pass it into the build using this standardized build argument, source date epoch. BuildKit knows what this is. It recognizes it and automatically clamps all the file timestamps inside the image to that exact value. The result? You get guaranteed bit-for-bit identical images from the same source code, which is absolutely critical for things like supply chain security. Now, as you start chaining all these advanced features together, you've got cache mounts, secret mounts, build args. Your build command can get ridiculously long and complicated. This is where we need to start thinking about orchestrating at scale. And the key to doing that is a tool called Dockerbake. So instead of writing some massive unreadable shell command, Dockerbake lets you define your entire build process declaratively right in a file. And the real key to its power, as you can see here, is that inherits keyword. You can define a base target with all your common settings, like building for multiple platforms or your cache configuration, and then have other targets for your specific services. Just inherit those settings. It's so clean, readable, and incredibly powerful. So why would you use Dockerbake? Well, for one, it replaces those fragile, hard-to-maintain shell scripts with a tool that was built for this exact job. It lets you manage really complex builds, it cuts down on repetition through inheritance, and best of all, when you tell it to build multiple things, it just hands them all off to BuildKit to be built in parallel. It's just a smarter way to work. Of course, even the best blueprints can have flaws. So what happens when things go wrong? Well, that brings us to our final section, debugging modern builds. Oh man, we have all been there. Your build fails on step 17 of a 20-step Dockerfile. The old way to debug this was just painful. You'd have to find the hash of the last successful layer, run it interactively, and then try to manually rerun the failed command to figure out what happened. It was awful. The new way is pure magic. You just add debug-on-r to your build command. Now, if a step fails, the build pauses and you are dropped directly into a shell inside the failed container at the exact moment of failure. You can check files, look at environment variables. You can figure out what went wrong right there on the spot. It's a lifesaver. And all of this really leaves us with a final thought. We spend so much time and energy engineering our applications, but so often we treat the build process like an afterthought, just the thing we have to do. With tools like BuildKit and Bake, we have the power to craft build systems that aren't just functional, but are genuinely fast, secure, and reliable. So the question to ask yourself is, are you treating your build process like a product? And are you engineering it for excellence? Thanks for tuning in.